Today's forecasts estimate 2.5 billion people lack adequate access to safe sanitation systems. As an answer to the United Nations call to action to eliminate the practice of open defecation by 2025, ISO 3500 was published. This effort was led by an international group of industry and subject matter experts, academia, prototype developers, non-government organizations, and national standards bodies. ISO 3500 seeks to provide general safety and performance requirements for the product design and performance testing of non-sewered sanitation systems for prefabricated integrated treatment units. It will apply to any integrated sanitation system that is not attached to a sewage or drainage system or electrical grid. By defining the boundaries for the corresponding innovations, this standard is intended to create trust and acceptance among technology users, entrepreneurs, and innovators, drive down cost, and provide governments and other potential investors with reliable criteria for making comparisons and procurement decisions. The standard can be broken down into three main categories. 1, documentation checks, 2, controlled laboratory testing, and 3, field verification of performance. The following sections are covered in the controlled laboratory testing: loading patterns, mechanical requirements, environmental parameters, human health parameters, air emission parameters, noise parameters, odor parameters, and electrical parameters. The controlled laboratory testing happens over a 32-day test schedule. Each one of the 32 test days has one of 3 designated loading patterns: 1 normal, 2 stress, or 3 diarrhea. The normal loading program is calculated from the manufacturer's declared uses per day and average amount of feces and urine per use. For the stress test, the maximum capacity is required from the manufacturer to calculate the stress loading. Diarrhea testing uses a ratio of 2 liters of water per 1 kilogram of fresh feces to simulate the real case scenario. During testing, the system can be loaded by real people using the toilet, or waste can be manually collected and deposited. Every day of testing will be scheduled between 6 a.m. and 8 p.m. to replicate real day-to-day usage. The standard provides a table that gives a schedule for each day, giving which parameters are to be tested, the designated loading pattern, and the suggested day and time frame. Now for the requirements and parameters the toilet must pass for the controlled lab testing. Mechanical tests are executed before the 32-day testing and focus on the front end. These tests are intended to prevent any slipping, tripping, falling, any damage from outside forces and leaking hazards, and to ensure flushing mechanisms can handle all permitted inputs. The first set of parameters with thresholds is for the environmental testing. Environmental parameters are tested for in the liquid output of the system. Parameters include chemical oxygen demand, total suspended solids, total nitrogen, total phosphorus, and pH level. COD, TSS, and pH levels must meet a measured range, while nitrogen and phosphorus are to achieve a 70 to 80% load reduction in the system. For load reduction of these nutrients, the initial input samples are tested to compare to the output of the system. These thresholds have to be met in at least 4 out of 5 test events, with failures no more than 20% variance from the threshold. The set of environmental thresholds applied to the system depend on the system's location. Areas with unrestricted access and public exposure are to meet more stringent thresholds. Next, human health parameters are tested for in solid and liquid output of the system. The 4 parameters are bacteria, helminth, protozoa, and virus. There are 2 criteria for passing each test. One is to meet the threshold values, and the other is to reach the log reduction values indicated in this standard. To meet the log reduction value, the initial input should meet a minimum required concentration. The concentration is achieved by spiking according to manufacturer's process. Indoor and outdoor air emissions are analyzed. Air emission parameters are captured twice on the designated test day from directly above the squat or seat pan, 1 to 1.5 meters from the floor. Indoor air emission parameters measured are carbon monoxide, nitrogen oxides, sulfur dioxide, hydrogen sulfide, volatile organic compounds, atmospheric particulate matter, and ammonia. The outdoor stack emissions are tested for the same parameters as indoor, plus PAH, oxygen, volume flow, and moisture content. Please note that for air emissions testing methods, there are recommended test methods and equivalent national standards provided in this standard. Similar to the air emissions, the noise test is separated into the indoor at the front end and external at the back end. The measurement point for front-end testing is exactly 1.2 meters from the ground directly above the squatting or seat pan. For the back end, the two measurement points are 1 meter out, 1.2 meters above, and 1 meter apart from one another. The noise level average must fall below a 60 decibel level, and noise must never exceed 85 decibels over 24 hours. Odor is separated into the indoor and outdoor measurements as well. The testing team vet a group of at least 4 people to be the odor panelist. Each panelist must pass tests to check their olfactory sensitivity. On testing day, at least 2 panelists stand in the sanitation system superstructure, and 2 panelists are outside near the system. Panelists record their observations after the events take place. A typical odor test day will have 4 fecal, 2 urinary, 2 maximum odor, and 2 random events. The observations are compiled, and a certain number must be within the acceptable range. The last set of requirements for controlled laboratory testing are electrical requirements. The system must pass an energy discharge test. During the test sequence, the power supply and remaining power will be disconnected and discharged. The tester will record the energy remaining in the system. If backup energy is present, the tester should check and record capacity of backup source. The first part of the standard is for documentation checks. This section includes all expected documentation from the manufacturer, as well as any tests that are required due to missing documents. The first clause of documentation checks is general technical information. This outlines all information the manufacturer is expected to provide. This includes the system's treatable input, capacity, minimum wait times between uses, how to safely dispose of menstrual hygiene products, and the serviceable life. The standard also specifies how the information can and should be shared. For example, the minimum wait times between uses should be in the user manual or on a data plate located in the system. The next section, General Safety, outlines all general physical requirements of the system. Some of the general safety requirements are: assembly design should deter removal or dismantling of critical accessible system parts. The toilet should function in an environment ranging from 5 to 50 degrees Celsius and within 20 to 100% humidity levels. Gas and accumulations, slagging, blockage of exhaust, and other potential hazards should be monitored, and the necessary mitigation measures should be implemented. These risks should also all be outlined in an iterative risk assessment created by the manufacturer. The following section is process design safety. This will include regulations on water seal depth, piping and connections, and mitigation measures through physical design to prevent infection from pathogens. It also covers safety measures for effluent reuse. For example, if hand washing water is produced by the system, it will be expected to meet WHO guidelines. Section number 4 in documentation checks is material safety. This section highlights all components and part requirements like cleanability, grip finish, durability, and fire resistance. Next is mechanical and electrical safety. Each of the subsections' applicability to the system is dependent on the system's features. For example, if the system has pressurized equipment with pressure levels greater than 50 kilopascals, or vacuum equipment with pressure levels lower than 50 kilopascals, then it must withstand mechanical loading pressures and structural strength safety factors. Other features covered in this section include pipes, hoses, tanks, extremely hot or cold surfaces, subsystems with radiation emissions, and all moving and rotating parts. The following section is user interface experience. This clause covers all user features from cultural requirements to markings and labeling. The standard describes the need for a toilet that will fit within cultural norms. Is the community used to water or dry flush, a squat or sitting toilet, toilet paper or water wash? The system should be comfortable to the user and achieve aesthetic satisfaction, and any labels, signs, warnings, and markings should be in the country's official language. This clause is intended to provide the user a safe, comfortable experience so the technology can be seamlessly implemented into the community. The clause maintenance design lays out the expectation that the toilet's maintenance, cleaning, and other upkeep is reasonable and within community capabilities. Maintenance activities and frequency of those activities are doable for users or professional service personnel on site, and all components that need to be replaced or serviced are easily accessible. Normal cleaning should not put the user in contact with hazardous material, and if it does, a trained service personnel should be required. User manuals are written in the local language and English language. And lastly, the full system shall be safely transportable. Sustainability is the last clause of documentation checks. This clause highlights the use and recovery of resources from the system output. Manufacturers will be expected to estimate the amount of nutrients like phosphorus and nitrogen in the final solid and effluent output. The proportion of the system's effluent and energy that can be recovered in comparison to its consumption level need to be provided by the manufacturer as well. A life cycle assessment should be conducted as per ISO 14040 and ISO 14044. Interested buyers should also be provided with recurring operational requirements, estimated annual energy consumption, and freshwater input in order to compare between systems and better judge the alignment of a system with their given location. The last section of this standard is for field verification of performance, which includes environmental and human health testing. This process depends heavily on the system type. The three types of systems are Class 1, which is a non-biological treatment process with one front end and one back end. Class 2 has a biological process and is one front end with at least one back end. Class 3 is any system with more than one front end. A Class 1 system will go through weekly human health and environmental testing. Its testing phase lasts for 30 days. Class 2 and 3 systems are tested for a minimum of 5 months. It is tested weekly for environmental parameters and monthly for human health parameters. Environmental testing in the field is like the environmental testing in the laboratory. Parameters, thresholds, and reduction values are similar, but for field testing, each parameter must hit a 75% pass rate for the system to pass. Human health testing in the field is also similar to testing it in the lab, except for the following exceptions. 1, there will be no spiking and log reduction values being tested. 2, protozoa sampling will validate the system's ability to treat for helminth. In that case, helminth testing is not needed. The system will need to have a 100% pass rate for bacteria, protozoa, and virus parameters. And that covers the contents of ISO 3500, a standard that breaks down into 3 main inspections and testing: 1 laboratory, 2 documents, and 3 field. Each provides the information on what is expected, the schedule of testing, and how it is to be tested. The safety and success of the technology rely heavily on the in-depth and multifaceted knowledge organized in this standard.